So in example 1 here in section 3.1, example 1, section 3.1, let f be a function with a domain R such that x squared for every number is this. So we want to plug in f of negative 6, root 3, a plus b, and f of a plus f of b, where a and b are real. So basically all we're going to do is plug in some values here. So what that means is I take a negative 6 and plug it in. So I'm plugging in negative 6, it's negative 6 squared, which is 36. I plug in root 3. Root 3 squared, they cancel each other out, giving you 3. A plus b, if I plug it in, that's a plus b squared, and I can FOIL all of this to get a squared plus ab, right? A squared, ab, b squared, so that's 2ab's. So a squared plus 2ab plus b squared. And this means I do first a, then b, so it's a squared plus b squared. So what is the range? Remember, range is the y's or all the outputs. So whatever you put in for x will be positive or 0. So what that means is if I plugged in a negative 10, negative 10 squared is 100. Plugged in 0, 0 squared is 0. If I plugged in 10 squared is 100. The point is, your range is all non-negative numbers because everything that you get is going to be a non-negative number. Whatever you plug in is going to be non-negative. So what that means is your range is from 0 to infinity. So in this problem, you need to find the domain. So the domain, we remember, it cannot be 0 on the bottom. And we also remember we have to have greater than or equal to 0 under a root. So in a fraction, you cannot have a 0 in the denominator. So we're going to look at the denominator first. So when I set this equal, 1 minus x cannot equal 0. I minus 1, and then I divide by negative 1. So we know that x cannot be 1 right now. But we also know the roots. You can't have a negative number underneath that. So that needs to be greater than or equal to 0. So I square both sides to get rid of the root. And I minus 4 on both sides. So x has to be greater than or equal to negative 4, and it can't be 1. And that will work every single time. It has to be greater than or equal to negative 4. So greater than or equal to negative 4, and it can't equal 1. So the domain is those two combined, meaning it starts at negative 4 as low as it can go. It goes the whole way up until it gets to negative 1, but remember, it can't be that. So then we leap over negative 1, and it keeps going until we get to infinity. And remember, the union is like you're jumping over what it can't be.
Wax on, right hand.
So find g of 5, g of negative 2, g of negative a, and negative g of a of that. So I plug in a 5 first. 4 plus 5 is root 9 on top. 1 minus 5 is negative 4, so 3 over negative 4. I plug in negative 2. 4 plus negative 2 is 2, so I get root 2 over 3 because the bottom is 1 minus negative 2. Plug in a negative a, I end up getting 4 minus a over 1 plus a, and that's under a root there on the top. If I plug in a negative, that means it's an a underneath and a negative on the outside, so it's negative root 4 plus a over 1 minus a.
Welcome to the party, pal!
Difference quotient, f of a plus h minus f of a over h is the difference quotient. So in example 3, simplify the difference quotient using the function x plus h minus f of x over h. So what that means is I take this, and everywhere where there is an x, I plug in an x plus h first. So that's what I did. X plus h, x plus h. Then minus the original equation with x's in it. So minus this right here, the original equation with x's in it. All that goes over h. So here is the first item, right, minus all of the second item all over h. All I need to do there is a whole bunch of foiling and a whole bunch of simplifying. So to FOIL the top, that's two of those. That negative needs to go through to both of those items. So I'm going to have to put that through to both of those. So x times x is x squared. That's xh, xh, h squared. That I can smush together and get 2xh, but here it's a 6x and a 6h. That negative needs to go through to everything, making that a negative x squared and negative 6x and a positive 4. So here's everything. So now I start smushing things together. And I have an x squared and a negative x squared, so they're gone. Okay, I have a 6x here and a negative 6x there. I have a negative 4 and a positive 4. So currently it looks like I have two of those, an h squared and a 6h. And because I have two of those, there's that. Every single one of those has an h in it.
Dad, I wish you.
So there's what I have, but every single one of those has an h in it. So I can factor that out. And now the top and the bottom all have an h, so I can take that out of each. Leave me with a 2x plus h plus 6 after I simplified it with the difference quotient.
I didn't have any corn.
Alright, a steel storage tank of propane gas is to be constructed in the shape of a right circular cylinder of altitude 10 feet with a hemisphere attached to each end. The radius is yet to be determined. Express the volume in feet cubed of the tank as a function of r in feet. First clue is the tank is made of a cylinder and two half circles. So remember, two half circles makes one whole circle. So thus, the volume of a sphere is this. So half spheres. Alright, there together would be one whole one. And there's the cylinder volume. So by just simply adding those together would be the equation that I need. So there's the equation that I have. They both have pi in them, so I'll take that out. And they both have two r's, so I take out a pi and an r squared. And I have a 4/3 r plus h left over. The reason why we are multiplying it by 3 to get rid of it is so that we no longer have the fraction. Okay, don't want the fraction anymore. So we get 3 pi r squared times 4r plus 3h, so that we can express this in terms. It says express the volume in feet cubed of the tank as a function of r, and we know that the altitude 10 feet with we know the altitude is 10 feet, which means that's the height, so that's why I plugged an h in there. So 3 pi r squared times 4r plus 30 is the answer.
The Human Torch is denied a bank loan.
So in example 5, two ships leave port at the same time, one sailing west at a rate of 17 miles per hour and the other sailing south at 12 miles per hour. If t is the time in hours after their departure, express the distance between the ships as a function of time. Basically, we're just going to be doing the Pythagorean theorem here. So one ship is going 17 one way, the other ship, which is west, the other one's going south 12. So the distance 17 squared, 12 squared is 289 and 144 when you add them together. 433, so when you square root them, we find out that the distance between the two is 20.81. So we plug that in for the r because that's the rate, so there would be your equation. So if you wanted to find the time that it would take to get there, you plug in a number for t. Piecewise functions we will get to when we come back.